Hello everyone and welcome back, it's Twiz. I'm very happy to have you back around here. I hope that the sound is a little better today and well, today we'll get started with procedural terrain generation instead of our sine waves. But before we start with that, we have a few minor things to fix basically. And well, the very first one is that I would like to be able to move a little faster. As you can see in a second, we're quite slow, and that's a little annoying. So if we want to move, we're quite slow, especially for our debug mode, it could be a lot faster. And another thing that we'll need to fix is that our cells currently only know about their neighbors within the chunk. So if we go inside here, we see that these inner chunk borders also get drawn, which is of course not good. So let's start with those two minor things and then go on with some noise generation and so on, so we can do a procedural world. So the input thing should be relatively easy going, I would say. So basically we want if our glfw get key, let's not do escape here, but glfw key left control. If that's activated, then let's say sprint is equal to true. And then of course we need the sprint variable that can just be a bool, and then we should probably also turn that off again. Well, we don't really need to do that, I think, because the next time input manager process input is called, the variable is going to start with false again. So it should be fine, but of course we'll need to pass that to our process keyboard function as well. So let's quickly say in camera that we also have our bool sprint, and in camera.h same thing. And what's your problem here? Okay, you're fine again, and you're fine again. Perfect. So then let's say if we do sprint, then let's do another factor in here. So let's say we have our float sprint factor. That sounds great. And then of course we need to multiply that here as well. And then let's just say it's 3 times the speed if it's true. And let's test that real quick. Should be fairly easy going though. So that's normal and that's fast. And as soon as I release the button again, we're slow. So that's great. That was a quick fix. And then we want to deal with our neighbors. So let's first of all go to our chunk, so we can set a reference to our world in there. Or do we have a reference to world in World Manager? That would be also enough. Nope. Okay, then chunk. First of all, let's also forward declarate the world. And then in here, just do world, world. And then in our chunk.cpp, we're just gonna add, where do we do that? Here. Nope. World, world. And then of course we would like to set them like so. Although, no, not the world manager. That's gonna be assigned individually. So what's your issue here? We got the int world manager world. Why are you unhappy with that? Let's check chunk H again. Ah, we're missing the world here. Perfect. So now you should be happy again. Great. Then where we create our chunks in world. Where is it? There we go. There, of course, we're gonna need to pass this world as a reference to chunks. Got another error here. Why do we have 2 times the functionality here? Ah, okay, in generate meshes we also check whether it's having the chunk already, just to make sure if ever we lose a chunk, then it's just gonna be recreated. But maybe we should say that we have an output here. Let's do something like that. Perfect. And then in our, well, I think it's in the cell. No, it's in the chunk as well, where we set the neighbors, I think. Set neighbors. And in here, of course, this is gonna get a little more complex now. So first of all, if x is bigger than 0, let's say we have a block there instead. Then, of course, we need to check whether our world x is instead... Actually, that's the world x, but we want the... So that's the chunk coordinates that we're going through here. But of course, we would like to have... No, it's the local coordinates in the chunk. And we, of course, need to figure out, first of all, let's return if we don't have that chunk, or sorry, if we don't have that cell. So if cell is not, then continue. And then if we have the cell, that's something we don't need then anymore. Then we want to do all of this stuff. And let's say if x is bigger than 0, then we want to set the neighbor in the direction west with x minus 1 and z. That's correct. If the world x is bigger than 0, and we have world, of course, then what we want to do is add the, let's remove that here real quick. What we we want to do then is get our western chunk. That should be chunks world x minus 1. But that's private. So let's say get chunks was a thing. Can we do it this way? I think so. And then if that's the case, of course, we also want to, if we found this chunk, if there's a west chunk, then we want to set the cell's neighbor as west chunk, cell's chunk size minus 1. So it's the, well, the easternmost cell basically. The z stays the same and the direction should be west as well, right? Yeah, because that's the direction in which this cell has this neighbor then, or basically this neighbor. Okay, so that's fine. Then of course we need to do that for all of the other things as well. So this condition is already correct. And then of course we need to do the same thing here. So if our x is less than chunk size minus 1, then we can set the neighbor within the cell. If it's instead, if the world x is, that's a little weird here, but if it's bigger, no, if it's, no, actually we can just say if our world exists. So if we have a world here, just dependent on that, because the other cases are already rooted out, we can just say that our east chunk is world get chunks world x plus 1 world z, and if we have that east chunk, then our neighbor is going to be in the east chunk cells, and it's going to be the first one, of course, in terms of the x-axis. So that should work perfectly fine. Of course, we'll need to define that get chunks function sooner or later. And then we're going to do a similar thing here, of course. And then if the world z is greater than 0 and we have the world, let's do the south chunk. That sounds great. Also with the x staying the same and the world z minus 1. That's great. And if we find that south chunk, then of course we want to put the cell like that. But if we have our world only, wait a second. Sorry, messed up. So if we have that south chunk, then we want to get the cell from there. And then let's finally do the northern direction. So if we have z smaller than chunk size minus 1, please do this. And if we have a world, then we want to do, well, we want to do the northern chunk, and the north chunk is going to be world x and world z plus 1. And then if we have that north chunk, then of course we want to set the cell's neighbor as north chunk x being the same and the z coordinate being 0. So the first z basically. So that should be fine. Then of course we need to set up our get chunks function. Let's do that in world h, and let's just say we have get standard vector of vectors of chunks and then return chunks. But of course we should actually put in, as we also did in our chunk definition, we messed that up a little. We actually only want to get one chunk, right? So we could just do it this way, and then we can also, instead of using those square brackets, of course we can just use a comma, and then that's going to be fine. So that should be fine. Why is there a problem with world x? Because we didn't define the function like that yet. And up here we're gonna do the same thing. So now that should be fine. We just need to work on our getChunks method. We're gonna have an int x and an int z, and with that we're gonna return the correct chunk. So basically, let's also call that getChunk instead, because it's a singular chunk, of course. What's your matter? Well, because we said we want to return that as a vector, we only want to return that one chunk, or a reference to it, basically. And then we add semicolon. Perfect. And in chunk, we'll of course need to rename that to getChunk everywhere. And as soon as we do that, that should be relatively perfectly fine. Do we need to define a getCell? No, because we have that x and 0. That should be perfectly fine. So that's working, I guess. So let's go ahead and, well, of course we're gonna need to set that up somewhere. So where are we? No, it's in set neighbors. It should be fine. The only problem is probably where we call set neighbors. Let's actually check that. Where do we do that? In hello, chunk.cpp, set neighbors. It's not only called here, I don't think so. Or do we call it in the constructor? Nope. Did we? Yeah, it's just for this current cell, so we probably call it in cell, right? And then the issue could be that we actually do that before we have the other chunks assigned. That could be a problem. Let's first of all run it and see whether we can actually build the whole project right now. Okay, so that doesn't work at all. Let's check our debug.log. Okay, so when we created the chunk, that was the issue. So probably while we create the chunk, we call that, right? Chunk, set neighbors, there. And I think what we should do instead here is in our world, we're gonna set the chunks as soon as we're done with all the creation. So set the neighbors as soon as we've created all of the chunks. So basically what we're gonna do here is loop through the chunks again. So we can actually just copy this whole thing. And then inside there, we can actually get our chunk. Let's say chunk is that, and then let's loop through all of the cells in chunk. So let's say cells equal to chunk get cells, current cell. Or what we should actually do is loop through the cells inside here. So let's say we're doing chunk size here instead. And we can just do that by doing chunk.get chunk size. Like that, and then in here we should be able to get that cell first of all, and then if we have a cell we should set the neighbors. Let's say chunk set neighbors for what do we need as an input there? Let's check real quick. Set neighbors. There we go, no inputs. For the current cell, nope, we looped through all of these cells in here already. So we don't need to do it here. We can just say chunk set neighbors. And as I just said, we don't need this then, neither this. Or let's say, hey mate, nice to have you around. Let's say we only do that if we find that chunk. So basically we check once more if we found a chunk, or then if it's null, then we just print that and continue on. So hopefully that's gonna work now. Of course not. Then let's have a look again at our debug log. Okay, so now we could create that, and then in basically the second row of chunks we get an issue. So probably what's going on is if we set the neighbor for the second row is then Z1, right? Because we had, no, it's looping through X first and then through Z. Interesting. So basically all the Z's are fine. We just have an issue with our X. Interesting. Let's go back to world then. And in here we create our chunks here first of all, so they should all be created. Chunk created until 9.9. So that's perfectly fine. But then in here, let's first of all print out that we want to set the neighbors. And then we're going to see whether we didn't get here or what was the issue. once again, setting neighbors for chunk at 0, 9 is an issue. And I guess that's gonna be the northern thing, because x is still 0 and z is at its max, so it should be north. So let's check the function here for northern neighbors. That should be down here, right? So we have a 9 here, so that's not smaller than chunk size 10 minus 1. I think so that we have chunk size is set as 10. Let's check that real quick. No, chunk size is 16. Then that doesn't make any sense. Or did we set that in, or did we override that in chunk.cpp? Nope, we didn't. Let's just print that out real quick to make sure. Let's just do it here if, well, here. Nope, I want the chunk size real quick. Like that, run that again and have a look. Okay, that went way further though. Chunk size is 16, okay. So what's the issue then with 0, 9? That doesn't make any sense, right? Setting neighbors for chunk at 0, 9. But then, shouldn't it either say this or that, I would suggest? Let's go to the definition again and just print out what's going on in here. So the chunk size got printed, so that's great. So then let's also say here that we actually found something within the chunk. Neighbor in chunk at that location. Yeah, let's just leave that location out. It's irrelevant here, because we print that a couple of times before. And then if not, so if we land here, then we want to do that. And outside chunk. And then let's check again. So this is 16 minus 1 is 15, right? Let's check whether we set that somewhere stupidly. Okay, we don't. So it should definitely be 16, not 10, so that shouldn't be an issue. Let's just run that again and see in which if condition it fell. Okay, let's go back to our debug, and in the end here, neighbor outside chunk. Do we have that before? Quite a few times actually. Let's see. Okay. So that's not the issue. Is it an issue with a world size or something like that? So it's just too much data. That could be a thing right now. So let's reduce that. Does it have to do with the world size here? Because that's 8, and then if we have 9, that's 1 too many maybe. Let's just try with 4, where we'll end up then. Maybe we have some where instead of chunk size we have world size. That could be causing the problem, I guess. Okay. So we're still at 0.9 and 0.8 was fine. And then that works until here. So maybe we should also print out some more stuff. Setting neighbors. It didn't get null, but let's go to set neighbors again. And then let's think about that. So we're looping through all of the cells in the chunk. That should be from 0 to 16, so that should be fine. And then if we have a cell in there with 0 to 15 basically, then we will just continue with our code here, and if it's not found, we'll continue with the next iteration of our for loop. So that should be fine. Didn't meant to do that. Okay, and then in here, basically that's still the problem, and I think we got a chunk, otherwise we wouldn't have gone into set neighbor, so that should be fine. We are passing the cell, which is going to be the neighbor. The only thing is, maybe we don't find that cell. So let's remove that here. Let's call that neighbor. And then let's do cell neighbor equals that. So then we can do if neighbor, then do this. Let's try again. Well, we got an error. Got the semicolon, as always. Okay, once again, check the debug log. Still the same thing, I would say. And it didn't actually crash there, right? Let's just go to debug mode then. Where were we at? Here, I think. Yeah. So why is it only a problem for the northern border till now? It shouldn't be a problem there, actually. Let's check again. We had that debug log here, and in here we're now working on chunk 09. That's nowhere near the northern border. So in here, we're also checking whether we have the chunk or not, so that shouldn't be the issue either. And well, these are totally working for the others, so the issue must be within set neighbors. Maybe we'll just ask our friend what's going on here and why we are not getting that to work. So let's just say, or let's just give him the last pieces of our debug log and say that it crashed. but let's go back to our chunk so he sees this method as well. That was the wrong window. Here we want to press enter. Yeah, north chunk should be fully initialized. Or don't we loop in world far enough? That could be a thing in this one. Ah, we define world size again here. That's stupid. That's gonna be the issue. You shouldn't do stupid things, mate. Still not. Now it's already there, an issue. That's interesting. That shouldn't accept this world size. Well, it should be noted here in world, because we set it in world H, right? Ah, we got 4 in there. Okay, so if it's 4, forgot that we changed that to 4. If it's 4, then there shouldn't be an error. It should just, as we check whether we have that chunk or not, it should just skip. So if we have the northern chunk, that's what we're checking. So the last debug line was enable outside chunk, right? Yeah. So it's outside the chunk. And then we need to, well, probably it's just getting stuck here. Let's go to that definition and say chunk is equal to this. And then before we return that, we check whether it's null or not. If it isn't, then let's return the chunk. And if it is, we're gonna return, well, either way we can just return the chunk. If it's a null pointer, then in our function here, we check that. If it's null, then we won't do this. So that should be fine then. Probably we'll need to do that for the others as well though, right? Okay, now that's weird. That's a lot of errors. Don't we have the include IO stream here in chunk? I would say so. Ah, so we got an issue here. Ah, well, because we don't include it here, of course. Okay. Next up, another issue in world CPU, no, in world H. At what line? Said it built successfully, it didn't. Let's try that again and then check our debug log if it's just closing right away. So now we're at 0s and 3 once again. It's still the same issue, right? Did he say anything else? Not really, no. But let's go through this then. So in our setNeighbors function, first of all, we check whether it's within the chunk. When it's within the chunk, it's easy. When it's outside the chunk, then or what we maybe should check whether the chunk size, no, that should be definitely fine if the z is smaller than chunk size -1, it's within, and if it's greater or equal to, then it's going to be with outside the chunk, and then we just want to see whether we have the world. If we have the world, then definitely outside the chunk, and we get our chunk. So let's say get chunk, or let's just add some statements here. Yeah, let's say yeah, why not? But we don't have a way, that's not going to be really helpful. Past, and then in here neighbor not null, and else north chunk is null. And let's check again what our output is going to say. Nothing, so it probably gets lost before in the getWorld function, in the getChunk function, I guess. So probably here, because that's the last thing it printed, and this didn't get printed, so didn't get print. So let's check here again. So do we need to do if chunks xz maybe? Shouldn't be an issue. If this isn't available, that should just be a null pointer. Let's just add, well, basically no, let's not add that. That's not gonna do anything. Let's see, let's do this here instead. And then let's say chunk is going to be chunks xz, and else chunk is going to be a null pointer. Ah, no, we're checking. That's the stupid thing, right? So we check here if it's null. So we don't want to do this then, of course. And we'd want to do that here. So then chunk equals to null pointer. And then, yeah, let's do this instead. Let's say we have a chunk And then, of course, we can get rid of this as well. And then let's just use cout here as well. And then try again. Maybe that was just a little messed up in here. Because, of course, if we try to access the chunk array outside of bounds, that could be a thing. Okay, so that's fine. 0, 3 was doing good. Chunk not null, retrieved successfully. So that worked perfectly fine. And then once again, at setting chunks for chunk at 0, 3. Okay, so that's working. Then we have the northern border once again. And then it says neighbor outside chunk. So the issue is still in get chunk or what? Let's just call that we're here. And then let's think that through again. We declare it, let's say, as a null pointer. And we also don't need to do this. Then we check the chunks at X and Z. And if it's null, then we just say that. Don't do anything with chunk, else we pass the chunks XZ. Okay, retrieving chunk at 0, 4. There shouldn't be a chunk at 0, 4. So what's going on then? Where was the get? Ah, well, it was in world H. Why does it have to be constant though? So it doesn't like this overload method. We're just gonna ask our friend. Okay, so once again, that's something we check, right? Okay, I thought it would pass a null pointer if we don't have, if we're out of bounds. Then let's just check instead whether we're within the world size for that chunk, I guess, as he suggests. So yeah, that's basically this, right? And then we can also get rid of all of that, I guess, but let's just leave it in for now. So before we do anything, we're just gonna check if the x of the chunk is within, so if x is smaller than 0 or z is smaller than 0, we'll return a null pointer. If x is bigger or equal to world size, or z is bigger or equal to world size, either of those 4 conditions will return a null pointer. So then we should be able to just do chunks, or chunk is equal to chunk. If we still ever have a null pointer here, then please break there. But of course, now that should also work for all of the other directions, right? So it should be working now, hopefully. Yes, it is. Perfect, finally. And then let's go within here again, and we don't have these chunk borders anymore. So that's really great. And we're also doing the right culling phase and all of that. So from below, our world should get mostly invisible, especially if we are directly below. So that's great. So we fixed that. That's lovely. Let's actually comment all of these though. And then in our chunk as well. I think the others should be fine too. The other directions, otherwise it would crash once more. Is it a problem if we have an empty else statement in C++? I don't know. We'll just try. Apparently not. Great. So then we can actually go on. One more thing I would like to do is only draw the chunks that are within a set radius to our camera or later on to our player. So we don't render the whole world all the time, but only what is near us. So I think I asked that our friend some time ago already in preparation of this, and there it is. Well, basically it says that we need to, of course, modify our world draw function. So let's go there, and where do we have that? World draw. Here we'll need to check whether it's within or not. So basically here. We also need the position of our camera, of course, but we should be getting that relatively easy. Let's say we have, so we go through from x min is going to be 0 to x max is going to be world size -1, I guess. But we want to check whether it's, yeah, that's a good thing. So for min, let me just set that up and explain it afterwards. Basically what we're going to do is before this for loop, we're going to calculate our int min x as our standard standard max, because we want the higher one of our 0 or center x, which we don't have yet, minus the radius. And then we probably need to include those. There should be an include statement for max. Accept, thanks. I hit accept. I thought so, at least. Returns the greater of the parameters. That's what I want, yeah. Okay, and the problem is probably that we don't have these yet. Okay, then let's say we have also a max x. Hello, Yaton. Is it just me or is the mic volume low? Is it still low? Please tell me, then I'll just push that. No problem. What's going on here? Why can't I type in here? Okay, hopefully it's better now. But I can also up it more if necessary. Okay, so basically, keyboard clipping louder than me. That's bad. Yeah, maybe I need to turn that. Let me... Is it better now? That's the big question. Just rotated it. Maybe it's a little directional inside, I don't know. But I could also use my headset instead. The mic is quite alright for a headset. Okay, and then let's see here. So basically what we would want to do here is not 0 and the center egg. 10 times better? Okay, unfortunately. Very nice. Thanks for telling. That's also going to be important for the, well, it's a video afterwards, so really bad if that's not nice. Thanks a lot. So inside here, instead, we want to do the world size -1. And then we want to do the center x plus the radius. So we're basically setting up our, well, let's just call them boundaries for now, which we'll check then later on. So here we can also do this 0 and the center z minus the radius. And then in here, we're going to do the same thing with the world size and the -1. And then we're going to have the center z plus radius. Then we still have the issue that we don't have the center and we don't have the radius, but we're just going to pass them as parameters. So let's say we have that just like that. Perfect. And then let's just copy that so we can put that in world.h as well. Where is it? Draw. There we go. And then that should be fine. So all of these can get calculated. And basically what that does is we can then calculate a difference from our, well, or basically we can check whether our deltas, which we're going to calculate now, in dx and in dz, which are going to be x minus the center and z minus the center. And then we're going to check if those multiplied or squared is bigger than the radius squared. Then, so basically the Pythagorean thing. I don't know the English word for it actually. So basically that a squared plus b squared is c squared. And then of course we want to do an else, right? No, we want to check again. We want to check again if we have a chunk at that x and z position. And then let's also change that to be smaller than, of course. So if it's smaller than, we are not skipping. Instead, we're checking if we have that chunk. But we don't need to check whether it's a null pointer, instead whether it's existent. And if it is, then we want to draw it. And we don't even need that. Neither this. And then we can just hit run and hopefully it's gonna be all fine and working. Somewhere here we have an issue. In draw world, right? In which file? An application? Ah, well, where we call it, of course, we didn't change that. We also need to pass the X, Z, and what was the other? X, Z, and the radius, basically. So where do we call that? Here. So there we'll need to get the player chunk X, player chunk Z, and then let's do, I don't know, 3 for now. Then we also need to get those. So let's say we have an int player chunk X and chunk Z. And then let's not do it this way, but instead say we have a reference to chunk somewhere or to the chunk size. Don't want to hard code that. We don't. We definitely need to put all of these sizes and so on in a config file instead of having them locally in all of these things. That's super annoying. What's your problem? Or is it just old? I think it's the old debug underline problem. Yes, it was. That can be super irritating. Okay, so basically we can see that we basically have the, well, we have 0, 0, and then we're not drawing too many more chunks, but if we move further out, especially with the faster thing, then we can see them getting drawn and undrawn. Let's basically set up this to be maybe 5, go with a much higher world size, and then we can see whether it's working fine or not. World size is here. Let's just go with 16 for now. That's going to be fine to see this thing. Okay, so we see a few chunks. If we go in that direction, we load more chunks. And if we look behind us, chunks are gone and chunks will come back until we, of course, hit the world border. Inside here, everything should be still fine, I guess. Yes, perfect. Okay, so now it's a much more performant version of our draw method because we don't draw things that are way too far away to see. Of course, we could increase our radius of, what did we set now? I think it was 5 or something, the radius. 5, yeah. Let's actually put that in a variable as well so we know what that's doing. So let's say render radius equals 5. And then let's put that here. Nice. So that's also working. Lovely. Then I would definitely like to do the Perler noise, and that's going to be probably a little complicated. So before we do anything, let's push our current state. Can you enable wireframe mode to show that you actually don't draw unwanted faces? Yeah, we can do that in a second. Let me quickly push all that we did here before we change anything again. That should be all, yeah. let's say that's working neighbors across chunks, working render radius. Then we can just commit that, push that. And what was the command for that again? Always confused that. I think we had that somewhere here too. Just comment out to see. Not cal face. I'm just gonna, or do you know it by heart? I think it's called in English, right? How that's done, or don't you? Because otherwise I'll have to Google it myself. Let's say we wanted OPENGL wireframe draw mode. I think it's just use GL lines or something like that. So let's just try that. GL enable, where could we put that? Maybe somewhere here in the beginning. Is it that? Not too sure right now. No, it's polygon mode, right? Yeah, it's polygon mode. I remember that now. Sorry for that. So that's the normal one. And instead of this here, just gonna do that. Why is there a G missing? Polygon mode. So basically you can see that from the inside we're not drawing anything. From the outside we can't see anything that we don't want to draw, I would say. So I'm pretty sure that we don't draw any faces we don't want to draw. So let's say that's working. Or don't you agree? And then instead of this, well, let's add a comment here, wireframe mode. Perfect. Yeah, we can do both. But I think we... No, we didn't do that here. Okay, so then that should be working. And we can actually finally go to the Perler noise. And in order to do the Perler noise, I also prepared a tiny little bit. And that's going to be to implement the Perler noise from, how was it called again? Solproc, from basically this repository. We're gonna download this one and this one, I think. So let's just copy the H, the header. Let's put that in our include folder. Perler noise.h. And then let's put a Perler noise.cpp here. So basically in the header, we're just gonna paste that, and then we're gonna go to the CPP, copy all of that, put that in there. And then in theory, it should already be working, I think. Or do we also need these others? We'll see. But what we'll definitely need to do is add them to our tasks. So we have not only our GLAD, but also our Perlen noise.cpp. And well, we should have the Perlen noise already be included with our include folder, right? So that should be fine, and we should be able to use it in our, well, in our world generation basically. So let's go to World Manager, and here we want to do that. So basically let's include Perlen noise here. Perfect. And then we're gonna rework this whole function that we worked quite a bit on yesterday, as we had some bugs in there. So basically, well, one more thing that we of course need to do is to get a function where we will calculate that fractal noise. So maybe we should just add that to World Manager, because why not? We can always move it somewhere else. So we're gonna do a double get fractal noise. So we can actually use multiple layers of noise on top of each other. Basically, that's what this does. So we're gonna do the fractal noise. We're gonna have a double X, double Y, double, no, let's just call that double Z. And then we're gonna need the sieve, Perlen noise, Perlen, and some octaves and so on. Then I think we can get rid of this auto type of thing. Let's check what Copilot has to say about this. That won't be the problem for here, right? Got the... We'll definitely need to, of course, set that up in our header file as well. Check again. Accept. That should only be Perlen noise.h instead. That's not changing anything. Maybe we'll need to also download these other files. I'm not too sure about that. You got a README in there though. Okay. Let's check that again. Yeah, then let's just add those ppm and pph as well. Probably we're gonna need those as well, I guess. Copy ppm.cpp. Well, we'll definitely need to move those in a second. Copy that, ppm.h, perfect. Then the h is gonna go in the include folder. The ppm cpp is gonna go in the lib folder. The header is already gonna be included, and the ppm cpp will need to include manually. Still an issue though.
Let's just run that and see whether it's... Okay, so it doesn't find that. So let's just ask our friend. What's going on with the Perlin noise namespace? Okay, interesting. But then how do we combine that with the rest? That's the big question, right? Okay, let's figure that out real quick. Okay, but I want to use it as a multi-layer noise for my terrain generation. Help me implement that. Okay, so what is he? Let's just move that to a new window. Close it here. Yeah, okay, so that's what you were giving me. Thanks for nothing then. Okay, but what about my issue with World Manager here? Something's wrong with Civ. Is that a thing? Would I've just needed to put it this way? And that's stupid. I did it here. So weird if it's only on one end. Yeah, still an issue here. Civ does not name a type. Yeah, okay. Can we just remove this Civ then? Perlin noise Perlin. And in World Manager, remove that as well. So in the header, I mean. Oh, in the CPP, we were in the header before. Warning, no return statement in function returning non-void. Yeah, okay, that's of course an issue. But we are not even calling that function yet, so it shouldn't be too much of a big deal. So let's go back to World Manager and then get all of that set up. So basically what we want to have is an amplitude. We want a frequency. We want a double max value. and we want a total. And then we're gonna loop through our octaves, which we pass in as our parameters there, or arguments. So basically what we're doing here is from 0 till, well, octaves -1, we want to increase I. And basically then we add to our total what we have as our Perlin noise if we multiply x and z by the frequency. And then I don't think that we need this 0, 0 here as far as I'm concerned. And then we multiply it by the amplitude. Okay, but apparently you need... Okay, z can have any value. Okay, then let's just put in a 0 there. And then let's see, Perlin has type qualifiers that are not compatible with the member function. Object type is constant Perlin noise. So couldn't we just remove this constant thing? And same thing in here. And then let's say we want to well, we have our... Let's also add our lacernity. I don't know how that's pronounced, but I don't care too much about that. So let's say persistence and double lacunarity. That's probably more like it. And then we, of course, need to have a look here. We have our amplitude, we have our amplitude multiplied by the persistence, and then we have the frequency multiplied by our lucenarity. And then after all of that, no, it's lucenarity, right? And then we're gonna return our total divided by our max value. So we normalize it to be between 1 and 0. And then where we use it in our world manager again, but further up where we design our chunk, basically that's gonna set our max height here instead, right? That's what we did for now. We got the sign and so on. We don't want to do all of that anymore. And instead now we need to set the I max height as as an int. So the I max height is gonna be int I max height equals to static cast int, and then we're just gonna put not the whole function and so on. We're gonna put a noise value that we create in a second, and we're gonna multiply that by our chunk get chunk height -1, right? That makes sense. So then of course we need to define our... Oh, why do we have max height here? That should be also I max height, I think. And then of course we need to define our noise value here. Noise value is going to be current x times the scale, I would like to call it now actually. But we can just say that scale now. Scale. And then what else do we need to put in there? We're gonna need our Perlin. Why can't we just use the Perlin from here? Let's just define that here. Basically, we are in the world manager, so we should, if we do anything, then we should do something like that, I guess. But I'm not sure whether we want to do that. this way. Let's then just leave those values as they are. And what's your problem? Yeah, okay. Apparently, currently this isn't working. Let's quick fix that and be happy with that. Where and how do I need to set that Berlin? Okay, we can just do it this way. We just need to create it once. So basically we could do that in world probably. Let's do that in world. What did he suggest? Nope, wrong window, this one. Well, well, that's actually also what he told us before, right? Yeah, just didn't listen that well. But I would like to do that in world and access that then from somewhere else. So let's say we do this, and then our seed is something, and of course that's just going to be an int. Or what do you need? Do you need a float? You don't care, okay. And then in our world manager we do have a reference to our world via our chunk, so we can say chunk world. No, quick fix that for me, I'm stupid. Well, that needs to be a dot operator because it's like that. And class world should now have a member like that. Let's just say in world we have a public member called Perlin. And what's that about? Too many arguments. Let's check that again. We have our X and Z, then we have the Perlin, and then we have 3 more. X and Z, Perlin, 1, 2, 3. Octaves, persistence, lacerity. I don't fucking know how to pronounce that. But why is that too many values in here? It shouldn't be. Or did we mess that up in World Manager H? XZ Perlin, well, we forgot to update the last value that we added there, the lacerity. Then you should also be fine, and then we might already have a working thing going on. What's the issue? Okay, you don't even know either, so let's just try. Forgot to add Perlin noise as an include here, of course. And then let's actually copy that to World CPP as well. And then let's just run that again. Still some errors. What's going on with my monitor? Just turned off. Weird. Okay. try get fractal noise const. Hey Qua, nice to have you around again. Where we at? You mean const here and world manager here. Backseat gamer, backseat programmer. Okay. Or don't I need to put it here as well? Thought so. So this one's definitely not working out. Not line 19, you mean in the definition here? Of course, yeah, stupid me. Good call. Thanks. Still underlined though. But that's what you meant, right? In the function definition? Or, well, basically behind the arguments here. Because if we have it here, we also need it at the function definition, right? Non-member function cannot have CV qualifier. Why is that though? True. Manager. Saving the day, boy. Thanks a lot, man. That was great. Well, it's a bit rough for now, I would say, but it's definitely procedurally generated. We'll probably need to work on how many octaves, how many, or basically all the input members that we did here, and then it's gonna look beautiful. And well, it's still working that only the things that are close to us are getting rendered and so on. So that's great. We also removed the inner chunk borders, or well, intra-chunk borders, whatever that's called. Let's just see. What did we pass here actually in here? So basically, let's reduce the scale. I think that's gonna help out quite a lot in the beginning here. Yeah, that's a lot smoother. What's going on with you here? Oh, okay. Fine. And then, well, I think we need to just test a few more values here in order to make it great. But it's already looking pretty neat. What I would definitely like in the long term, cheaper than the Copilot license. Okay, yeah, then I'm just gonna hire you for nothing or what? Can you beat the $10 or what is it? If you're here for free, then yes, sure. Okay, let's say we of course want long term to have basically some flat areas in the terrain and also some more mountainous type of stuff. So I think what we need to do is actually not add too many more octaves, but let's just try. Last offer €5. Yeah, then, well, Sorry, not sorry, but thanks a lot. Okay, that's not changing anything. Well, a little tiny bit, not too much. So the last thing, basically what I want to do real quick is just let this guy explain all the things. That's the wrong window. Wrong window still. Where is it? This one. Okay, help me understand the noise, well, the arguments for our function in more detail. Or let's, well, I wanted to call it which function, but it understood that it's about the get fractal noise. Great. Okay, that's basically nothing. The number of noise layers, yeah, okay. And then how much each successive octave contributes to the overall shape. So it's getting less, right? And that's what we're also doing, yes. Then the lacunarity, lessenarity, whatever, controls how much the frequency increases with each octave. Okay, so I think 0, 5, and 2 are balanced quite nicely, actually. I'm not too sure about that, though. So let's say we wanted to just up that by that, so the frequency increases, then we should have more frequent small bumps, as far as I'm concerned. Yeah, I would say that's more frequent bumps here. So then let's try the other way around. We're just gonna decrease that real quick. Yeah, that's helping. Can't you use like phonetic language, or how's that called again? Phonetic signs. I don't fucking know. Yeah, basically that's looking a lot better. Much more smooth valleys here. And then I think if we were to set our chunk height to something like 64, wait a second, chunk height to 64, then maybe that's gonna look even better. But probably we'll need to work on these numbers then again. Yeah, that's a little too much maybe for the current settings, but it's looking pretty neat, I would say. Although, of course, we also want some valleys in between all of these mountains and so on. So maybe we'll just decrease that even more and go with a few less octaves. Yeah, looking already pretty good. Maybe we'll go with a little less chunk height, so it's gonna be even. So we have some mountains, but not too much. Where's chunk? Chunk H. Let's just try the 32. And then that's already looking pretty nice. Of course, later on we want to add other things like, well, trees, plants, resources of all kinds. And then, well, the world is not gonna look as boring. And I'm probably gonna figure out some better values for our terrain. So I already like it quite a bit, but it's not perfect yet. Let's actually see how big is our terrain. I think we did something like 16 by 16 by 16 by 16, right? So chunk size and world size are 16. World size is, and chunk size is as well, yeah. So that's great. We can also, of course, get a way bigger world now, I think, as we're not drawing all of that, but in the creation it's gonna take very long as we're not yet generating the terrain on the fly, which of course would be a thing that's probably well, would be nice to have, definitely. And I probably should just get rid of all of these draw calls. Let's do that now. Setting neighbors and that kind of stuff. Let's leave the error here. That's also gonna be kept. And well, chunk created, we also don't need to worry about. Okay, and we can also get rid of that, of course, but no need to worry now. And now we should have a fairly huge world to go through. And then of course we can also just change our seed for the Perlin noise. So we'll have a totally different world. Well, basically now it's not gonna be totally different, it's just weird valleys with some, so weird valleys of grass with some dirt blocks sticking out from time to time. But basically it's kind of huge. So, there we go. Took a moment to unload. And then, what did I say? Yeah, that's the seed. Let's just go with 42, as it's the answer for everything. Check that for now. And then I'm thinking about whether we should add the model loading already or not. I think that would be a good topic for the next stream as well. So probably we're not going to deal with that today. And we just need, or I'll need to find some better parameters for the stuff. And of course, we're also gonna change the terrain generation a little bit, I guess by interfering with what the noise generation put out. So not only our get fractal noise is gonna define our terrain, but also long term, of course, we want to have some features in the terrain. Let's say we wanted to have, I don't know, a river or something like that. Then it would be nice if that river also is flowing from a high point to a low point or something like that. But that's not gonna be that soon, I think, because it's not really an important element for the gameplay. that I'm planning on. So thanks, mate. So probably I'm just gonna end it here. And then continue the next time with the model loading. Yeah, and of course, as soon as we get the large language models inside here, then we're gonna get some money, that's for sure. Okay, so with that said, I really hope that you enjoyed this stream, even though it's probably not that entertaining, as it's quite boring to watch somebody program, I guess, but some people stayed around, so I guess that's fine. I wish you all the best. Have a great Sunday, and well, see you next time, I guess.